Good morning, everyone. M- Myself, Achyut from Department of Electrical Engineering, IIT Madras. Today, I'm going to give a presentation on the man who saw tomorrow. These are the outlines we are going to see in the presentation: introduction, early life, inventions, the motivation for the ECD, uh, etc. It's hard to look around in today's technology-driven world and not see something that exists because of inventor Stanford.R.Ovshinsky. When you turn your flat screen TV on with the click of a remote, when you see a solar cell powering a home, when you save a photo on your smartphone, you have Ovshinsky in part to thank. Ovshinsky is arguably one of the greatest thinkers and inventors you have ever heard of. He's been called his generation Thomas Edison, and his brilliance compared to that of Albert Einstein. He was ahead of his time. Benjamin Ovshinsky was a father of Sir Stanford.R.Ovshinsky, a Lithuanian Jew who emigrated to the United States at the beginning of the 20th century, certainly did not expect that his son Stanford would become one of the greatest inventors of his time, and that the idea he proposed would point the way for future generations to follow. In the given pic on the right side, we can see Sir Benjamin Ovshinsky, who is the father of Sir Stanford Ovshinsky, and the Ovshinsky is standing in the middle in the front. In on the left side, we can see Sir Stanford Ovshinsky with his wife Iris Dibner. Ovshinsky often took his son to nearby factories from which he sourced unwanted damaged or broken parts and equipments. Thanks to these tools, Stanford has the opportunity to see many missions and becoming interest in their construction. It is not surprising that after graduating from high school, and during even his education, he was looking for a job related to mechanics. Coming to his education, Ovshinsky dropped his studies after high school and wanted to work in a mechanical factory. He loved mechanics from his father too. He don't have a bachelor's or a PhD degree, but with the research and inventions he made, he has many honorary degree of science. Now coming to the first invention. Sir Senior Stanford Ovshinsky used to work in a Goodyear factory. While working in a Goodyear factory, he understood that unnecessary movement, whether mechanical play or chatter of the cutting tool, limited lattice speed and efficiency, wasting energy and damaging both the machine and the piece. Began work through destructive vibrations and heat. He began replacing the traditional cast iron bed typically on legs with a massive block of welded steel. The slide which held the cutting tool was another piece of hardened and ground steel, and there were no gears, belts, or screws, just a chain drive from powerful motor to the chuck. With this design, nothing could move except the simple wedge pushing in the slides and moving them forward. As a result, lathe could move much faster and deeper cuts than anyone had, though possible with increased efficiency as there was no chatter and there was no heat buildup and there was no use of using coolant. Most important was the chuck, the radial clamp whose jaws had the piece of machine. Instead of tightening by screws, it was held by hydraulic pressure. Now coming to the second invention, which is nothing but automatic tractor and the industrial computer. He automated a tractor by adding an electrical control system. To run the tractor on autopilot, Ovshinsky set a program that would tell you to turn right and do a 180. And of course, today with GPS, it would be a no barrier. The tractor would work a field by running down one side and on, receiving instructions from a drum and a gyroscope. Turn around and repeat the process along a parallel line, continuing until the entire field was worked. It was a closed loop based system. And this was the image of an automated tractor which was built by Sir Stanford.R.Ovshinsky. And he applied for a patent for the automatic tractor model, and he even got a patent in the year 1954. One of the Ovshinsky's automotive inventions was a new kind of automatic transmission. Unlike the existing hydraulic system, which wasted power and fuel because of slippage, the design used electromagnetic clutches that adjusted gear ratios in response to road conditions. It shifted by itself. Ovshinsky filed for a patent on this invention in Jan 1955, and it was issued in 1957. Another invention responded to reports that children were being injured or even killed by a new power window that hub motor was first to make. The children would push the button to close the windows, and they couldn't stop the thing, and it was like a choke. To remedy this tragic situation, he invented a sensor based device to prevent the window from closing if it is sensed a hand or other object in the way. But when Ovshinsky showed this invention to engineer at Ford, explaining it would cost only pennies when produced in volume, that reply was, "We don't spend pennies when we don't need to." Coming to the one of the most uh, good invention of Sir Stanford-Ovshinsky was electric power steering. The most important invention Ovshinsky produced at up was electric power steering. The invention was simple application of cybernetics, a sensor based on a few inches of rubber tubing inserted into the steering column registered turning resistance, and a potentiometer would respond by sending current to two slippage electric clutches to the match the resistance with right amount of power assistance. Such feedback offered the same kind of closed-loop intelligence that human brain use in corrective decisions based on sensing. Even in icy weather, Ovshinsky claimed his power steering was more sensitive and much safer and less expensive than the open-loop hydraulic approach, which could lead to loss of control. Ovshinsky device also made for a smoother drive by eliminating road vibrations because the slippage of clutches changed with the resistance. Schizophrenia and epilepsy. Iris was a new person who came into the life of Sir Stan Ovshinsky. Ovshinsky and Iris worked in the areas of neurological field on schizophrenia and epilepsy, which are type of mental disorders. He was exploring this area to develop the cybernetic analogy of animal and machine control and communication. He began to ponder whether both schizophrenia and epilepsy might have to do with changing electrical thresholds, building on a hypothesis that electric waves from the brain control human actions. He suggested that because of an injury or some genetic problem in a human brain, those waves might become a wrong ones and might result in a neural disease. He even conducted research at Wayne University. He proceeded to explore the neurophysiology of the brain experimentally by implanting electrodes in the brain of cats and monkeys. The group helped by making the group at Wayne University has helped Sir Ovshinsky by making micromanipulator controlled needles for implanting the electrodes accurately in the brain of monkeys and cats. He finally published a paper on nerve impulse. Ovitron, which is a turning point for Sir Stanford-Ovshinsky, which made him invent many other things. The paper on the nerve impulse has helped to propose an analogy between the signals transmitted from one neuron to another and electrical circuits. Conceiving neural circuits cybernetically as organic equivalents of the sensing and feedback mechanisms of automation, he began to think of nerves cell as a kind of switch that allows to pass once an electrical or chemical threshold is reached. He wanted to locate the threshold at which the cell is fired and identify the electrochemical process that allowed the impulse to pass between the cells. To answer this, he built a physical model. He built a physical model to that work the way nerve cells do, with a semi-permeable membrane that allowed it to fire when the activating impulses reached a certain threshold. He assembled a device that uh, looks like an electrolytic battery with a tantalum electrodes immersed in a hydrochloric acid electrolyte containing small amounts of zinc. So when he applied an AC voltage, there was no current flow because of thin insulating oxide film on the electrodes. But when an additional positive DC voltage was introduced by a third non-reactive electrode, the device switched on. Reversing the DC polarity switched it off again. Ovshinsky thought of the electrolyte as being like the fluid surrounding neurons, and more importantly, of the oxide coating on the tantalum electrodes as being like the cell membrane, a semi-permeable barrier that allows transmission when stimulation reaches a certain threshold. And here in the diagram, we can see the working of an ovitron, which is in the off condition and the on condition. In the on condition, a non-reactive electrode was being introduced, and in the off condition, there was an oxide film, insulating oxide film of electrodes on electrodes. And in this pic, we can see the Ovitron promotional photo where Sir Ovshinsky was promoting the Ovitron switch. The Ovitron was basically impressive switch. It was extremely fast with a switching speed in milliseconds, and it yielded an enormous power gain. The DC current of only a few milliamps at about 3 volts could control an AC current of as much as 20 amps at about 100 volts. On July 8, 1959, after roughly 8 months of development, Sir Ovshinsky publicly disclosed the Ovitron. They began working on ways other resources could be coming to the important part and phase of Sir Ovshinsky's life, which is nothing but energy conversion laboratory. In Jan 1960, Stan Ovshinsky and Iris set up a new company known as Energy Conversion Laboratory. The mission of this energy conversion laboratory was using science and technology. They wanted to solve the problems, societal problems. In defining social mission, Stan and Iris has focused on the topic of energy, particularly the problems resulting from self on oil. They began working on ways other resources could be converted into energy. And to signal this research direction, they named their new company Energy Conversion Laboratories. And this was the motive and the coin which was made by Energy Conversion Laboratory. They believe that energy and information are both sides of a coin. Uh, let's see early energy conversion work. Ovshinsky thought about how to use hydrogen as a clean fuel. He conceived of a complete energy system he called the hydrogen loop, in which the solar generated electricity would electrolyze water and create the hydrogen to be used as fuel either in combustion fuel cells or other devices. But the problem with the thing is that there were nothing to store in hydrogen, and the problem is only solved after 2 decades at ECD. And here we can see that Ovshinsky is explaining the hydrogen loop, and here we can see that he is experimenting with hydrogen conversion in the year 1960. Ovshinsky interest in hydrogen bore fruit when ECD hydrogen storage program led to nickel metal hydride battery, a hydrogen fuel cell, and a hydrogen powered car, which we will see in the upcoming slides. Search for new switching materials. Almost all solid-state physicists dismissed amorphous as disordered materials in favor of crystals till the year 1960. Turning to amorphous materials for switches, Ovshinsky opened up a new line of research that would be enormously productive. The only book with any information at all on the subject of amorphous materials was Thomas James Gray's The Defect Solid State, published in the year 1957. He began to think of compounds of chalcogenide might be a promising replacements for the oxides he has used in Ovitron. He focused on tellurium and found to get switching effect, but he came to know tellurium by itself doesn't work. And in this diagram, we can see a regular periodic structure of a crystal and irregular structure of an amorphous glassy material. And this was the book cover in which there was only mentioned about the amorphous solid state materials. As he could not afford expensive evaporation and deposition equipment for creating thin films, he grounded his materials into powders and experimented with combining them. He grounded his materials into powders and experimented with combining them. For greater stability and conductivity, he combined tellurium with elements like arsenic or antimony from neighboring groups. When he inserted his probes into these powders and he started slowly and gradually increase the voltage, a cross pattern was observed. The cross pattern indicated an extremely rapid, almost instantaneous switching from insulating to conducting and back. Ovshinsky has created his first amorphous threshold switch, for which this cross became his electronic signature. And we can see in this diagram, we can see an oscilloscope trace of a cross pattern. The search for new switching materials. After finding a new switching material, a paper was published. A article was published in New York Times in the year 1968, stating glassy electronic devices may serve as transistors. The thin film amorphous chalcogenide semiconductors that developed from his threshold switch has found their principal applications in advanced information technologies in devices such as optical and electronic memories. When he has given small current pulse, the material will come to low resistance state, and when a strong pulse is given, it again becomes a non-conductor. So this is a bistable device based on the slightly different composition of the material and used in a threshold switch, which has become the basis as a fast rewritable electrical memory. Optical phase change memory. Ovshinsky has felt that the above phase change switching could probably be induced by laser light and thus become the basis for optical memory. He, with Julius Feinleib, who is an assistant professor of MIT, and laser expert Sato Iwasa, who used to work in Honeywell, has created an experimental setup to check this effect. Feinleib and Iwasa has succeeded in showing that laser could crystallize a tiny spot on the amorphous material to indicate a 1 or a 0, and by applying another laser pulse to the same spot, they could cause it to change phase back to amorphous. This is a mechanism behind the rewritable optical memory, a technology that would lately become widely used in CDs, DVDs, Blu-ray, and high definition discs. Optical phase change memory was first commercial application of Ovshinsky effect. The collaboration between ECD and the newly formed Intel by Robert Noyce and Gordon Moore resulted in an important new kind of integrated circuits. Initially made in limited quantities by ECD, the 256-bit memory and was later manufactured by Intel and called the read-mostly memory. It avoided certain serious problems of that time existing read-only and random access memory. And this was in the diagram we can see the first amorphous semiconductor memory, which was made in the year 1950, and it was a 256-bit RMM array. RMM stands for read mostly memory. And this was the latest application of Sir Stanford.R.Ovshinsky's invention of switching materials, which is a 3D X-point memory, which was a joint project of Micron and Intel. Now coming to amorphous silicon solar cells. The largest and the longest program for ECD was in solar energy, beginning in late 1970s and continued till the Ovshinsky's death. He did not invent the material for amorphous silicon solar cells, but ECD researchers repeatedly discovered ways to increase their efficiency. The first way they found to increase the efficiency is each cell consisted of three layers of hydrogenated amorphous silicon produced from cerium gas by plasma deposition. The p-type layer doped with boron and the n-type layer doped with phosphorus sandwiched a thicker undoped or intrinsic layer. These were deposited on a stainless steel substrate. The other way to increase the efficiency was stacking of 2 or 3 thin solar cells also opened the way to spectrum splitting, developed in 1980 by Steve Hudgens. ECD did not make this process, but ECD perfected the process, and nobody else knew how to make silicon germanium alloys better than ECD. And in the pic, we can see Sir Stanford.R.Ovshinsky with a solar cell, and the solar cell which was made by ECD was in the hand of Clinton, who was the American president at that time. And this was the first amorphous silicon solar calculator. Hydrogen and batteries, 1980 to 2000. Like a solar cell, a battery is an energy conversion device. But instead of converting light into electricity, it converts chemical energy to electricity. In 1960s, Ovshinsky believed that hydrogen could be a key to solve the world's energy problems. By the year 1982, they created a prototype for this new type of batteries and applied for patent. The patent recognized that E-series was the first nickel metal hydride battery that could be commercialized. ECD's nickel metal hydride batteries found their way into many commercial products, including digital cams, laptops, calculators, and into electric and hybrid cars also. The earlier batteries had too little power and too short a cycle life. Soon becoming sluggish, they would stop working because the oxides that formed in the harsh alkaline environment prevented them from recharging. The key to make a commercial nickel metal hydride battery was to use the Ovshinsky's disordered material in its negative electrode. Nickel metal hydride batteries and electric cars. The batteries based on Ovshinsky's original patent were excellent for slow rate applications such as radios, cams, and computer, but they couldn't charge and discharge quickly enough to be used in cars where the batteries needed both to absorb the car braking energy quickly and to release it quickly. In advanced version, nanoparticles of nickel alloy suspended in porous oxide layer that forms on the hydrogen storage material catalyze the reaction and greatly speed the charging and discharging process. This breakthrough made ECD nickel metal hydride battery feasible for electric cars, and this was the first electric car which was based on the nickel metal hydride batteries. But due to some funding problem, uh, he couldn't proceed the process. So General Motors has funded the ECD for an electric car based on nickel metal hydride batteries, and this was the first General Motors EV1 vehicle. It wasn't failure at that time, but it was completely new and completely technology based car. Coming to the next slide is the hydrogen cars. In late 1990s, Ovshinsky also began to develop a car with an internal combustion engine fueled by hydrogen, which is a clean and non-polluting energy source. Ovshinsky aimed to store the hydrogen in the form of solid hydride placed in the tank of the car. This material would release only as much hydrogen as was needed. and this was the 2002 model, and this was the 2004 model, and this was the 2005 model of, and these are the three hydrogen cars. Stan and Iris, which and the mobile hydrogen. In this diagram, we can see Stan and Iris and the mobile hydrogen refueling station. And this was the reference which I have taken. Lillian Hoddsen, The Man Who Saw Tomorrow, The Life and Inventions of Sir Stanford.R.Ovshinsky, which was a book published. Thank you.